Our sense of touch is actually several senses: pressure, warmth, cold, and pain that combine to produce other sensations, such as hot. Pain is your body's way of telling you something is wrong. There are different nociceptors, sensory receptors that detect hurtful temperature, pressure, or chemicals. Gate control theory, founded by Ronald Melzark and Patrick Walls, is the theory that the spinal cord contains a neurological gate that blocks pain signals or allows them to pass on to the brain. The gate is opened by the activity of pain signals traveling up small nerve fibers and is closed by activity in large fibers, or by information coming from the brain.
Pain is not merely a physical phenomenon of injured nerves sending impulses to a brain area. When we are distracted from pain, a psychological influence, and soothed by the release of our natural pain-killing endorphins, a biological influence, our pain experience diminishes. Therefore, sports injuries may go unnoticed until after the game.
The brain can also create pain. Phantom limb sensations is when the brain misinterprets the spontaneous central nervous system activity that occurs in the absence of normal sensory input. Even those born without limbs sometimes perceive sensations from absent arms or legs. A point to remember: we will feel, see, hear, taste, and smell with our brain. Memory of pain often differs from the pain we actually felt. Because people overlook a pain's duration, their memory snapshots instead record two factors: their pain's peak moment and how much pain they felt at the end.
Our perception of pain also varies with our social situations and our cultural tradition. We tend to perceive more pain when others seem to be experiencing pain. When feeling empathy for another's pain, a person's own brain activity may mirror that of the other person. Because pain is both a physical and psychological phenomenon, we can control pain with drugs and surgeries or distracting people with pleasant images. (21.4) Body position and movement. Sensors in your joints, tendons, and muscles enable kinesthesia system for sensing the position and movement of individuals' body parts. Vision interacts with kinesthesia. Your vestibular sense is the sense of body movement and position, including the sense of balance. Gyroscopes are used for this sense of equilibrium in the ear. The semicircular canas and vestibular sacs connect the canals with the cochlea and contain fluid that move when your head rotates or tilts. This movement stimulates hair-like receptors, which send messages to the cerebellum, enabling you to sense your body's position and maintain balance.
When you spin around, neither fluid in your semicircular canal nor kinesthetic receptor immediately returns to a neutral state. The dizzy after effect fools the brain with the sensation of still spinning. This creates the principle that mechanisms that normally give us an accurate experience of the world can, under special conditions, fool us.
Taste is a composite of 5 basic sensations: sweet, salty, bitter, sour, and umami. Evolutionary psychologists explain that taste exists for more than our pleasure. Pleasurable tastes attracted our ancestors to energy or protein-rich foods, which enabled their survival. This chart shows what different tastes indicate. Taste is a chemical sense. Inside each little bump on the top and sides of your tongue are 200 or more taste buds, each containing a pore that catches food chemicals. Into each taste bud pore, 50 to 100 taste bud receptor cells project antenna-like hairs that sense food molecules. Some receptors respond mostly to sweet-tasting molecules, others to salty, sour, bitter, or umami. An interesting fact about taste is that taste receptors reproduce themselves every week or two. So if you burn your tongue, it's okay. Another thing to consider is as we get older, the number of taste buds we have decreases. Also, smoking and alcohol accelerate these declines. Smell is also a chemical sense. Molecules of substance reach tiny clusters of millions of receptor cells at the top of each nasal cavity, each with about 350 different receptor proteins. Odor molecules trigger combinations of receptors and patterns that olfactory cortex interprets. The receptor cells send messages to the brain's olfactory bulb, then to the temporal lobe and to parts of the limbic system. For humans, the attractiveness of smells depends on learned associations. As good experiences are linked with a particular scent, people come to like that scent, which explains why people in the US tend to like the smell of wintergreen, which they associate with candy, more than those in Great Britain, where it's associated with medicine.
Section 21.5 Sensory Interaction. Our senses are not totally separate information channels. In interpreting the world, our brain blends their inputs. For example, smell can change our perception of taste. A drink's strawberry odor enhances our perception of its sweetness. Likewise, touch can influence taste. For example, a potato chip can taste either fresh or stale, depending on its texture. These two examples show sensory interaction at work, the principle that one sense may influence another. Vision and hearing may similarly interact. For example, a sound may be easier to hear when accompanied by a visual cue. Bah! But what do you suppose happens if the eyes and the ears disagree? What if we see a speaker saying one syllable while we hear another? Surprise, we may perceive a third syllable that blends both inputs. This phenomenon is known as the McGurk effect, after its discoverers, psychologist Harry McGurk and his assistant John MacDonald. This table shown here exhibits words that can be expected in the McGurk. For example, when you hear bean but visualize beep, the expected McGurk word is beam. Touch also interacts with our other senses. In detecting events, the brain can combine simultaneous touch and visual signals thanks to neurons projecting from the somatosensory cortex back to the visual cortex. Our brain even blends our tactile and social judgments. For example, after holding a warm drink rather than a cold one, people are more likely to rate someone more warmly, feel closer to them, and behave more generously. Physical warmth promotes social warmth. After being given the cold shoulder by others in an experiment, people judge the room as colder than do those treated warmly. Social exclusion literally feels cold. For some reason, holding a heavy rather than light clipboard makes job candidates seem important. Holding rough objects makes social interactions seem more difficult. These examples of embodied cognition illustrate how brain circuits processing our bodily sensations connect with brain circuits responsible for cognition. So, the senses interact. But in a few select individuals, the senses become joined in a phenomenon called synesthesia, where one sort of sensation produces another. Thus, hearing music may activate color-sensitive cortex regions and trigger a sensation of color. And thus, the river of perception is fed by sensation, cognition, and emotion.